Welcome back to my channel. Today we explore support vector machines, one of the most powerful and mathematically elegant algorithms for classification. SVM is mainly used when we want a clear, strong boundary between categories. SVM is an algorithm that tries to find the best separation boundary between two classes. This boundary can be a line in 2D or a plane in higher dimensions. The best boundary is the one that keeps the classes as far apart as possible. The intuition is simple. Instead of just drawing any line between two classes, SVM draws the line that has the largest margin, meaning it keeps the classes far apart. This makes the model stable and reduces errors on new data. Support vectors are the most important data points. These are the points closest to the decision boundary. If you remove them, the boundary changes. They act like the pillars that hold the boundary in place. A large margin means the algorithm is more confident and generalizes well to new data. A narrow margin usually means the model is tightly fitted to training data and may overfit. SVM works very well when data can be separated using a straight line. But even if data is not linearly separable, SVM can still handle it using something called the kernel trick. The kernel trick is a technique where SVM transforms data into a higher dimension so it can draw a clean boundary. For example, two overlapping circles in 2D cannot be separated by a line. But if you lift them into 3D, a plane can easily separate them. This trick makes SVM extremely powerful. For example, in spam classification, each email is converted into features. SVM tries different boundaries and chooses the one that perfectly separates spam from non-spam emails with the largest margin. SVM has a few settings you can adjust. The C parameter controls how strict the separation should be. A high C forces the model to separate everything perfectly. A low C allows some mistakes but makes generalization better. Gamma controls how curvy the boundary can become. SVM is extremely effective when data has a clear separation margin. It also performs very well when we have many features, like in text classification or image recognition. SVM is powerful, but it can be slow when datasets are extremely large. It also requires careful tuning of hyperparameters. If the data is very noisy, SVM may struggle to find a stable boundary. SVM is used in many real-world applications, including face detection, handwriting recognition, spam filtering, and bioinformatics. It's especially good when the dataset is not too large and has a clear structure. To summarize, SVM is a powerful algorithm that finds the best boundary between classes. It uses support vectors and maximum margin to keep predictions stable. And with kernels, it can handle complex, non-linear data easily. Thank you for watching. In the next video, we will explore K-nearest neighbors, a very intuitive and visual algorithm. See you in next video.